Hi students, today we discuss mechanics in that motion in a plane. Now, here last class already explained motion in a straight line, now we discuss motion in a plane. So, if the motion of a body confined to a plane, such a body is called what? Projectile, prakshipta vastu. Now, what is projectile? First of all, what is motion in a plane? Motion of a body confined to a plane, motion of a body confined to a plane. So, body moves along two directions. If the motion of a body confined to a plane, plane means what? XY plane or YZ plane or ZX plane, like this. If the motion of a body confined to XY plane or YZ plane or ZX plane, so then that motion is called what? Motion in a plane. So, here body moving two directions, body moving two directions. So, if the motion of a body confined to a plane, that body is called what? Projectile. Now, so what is projectile? How we define projectile? Here a body projected with some velocity at angle other than 90 degrees, with the horizontal is called a projectile. So, on the time if a body projected with some velocity u, angle how much here? Angle of projection 90 degrees, other than 90 degrees. So, on the time body traces a curved path in a vertical plane. Now, here O be the origin, x and y are coordinates, x axis, y axis. On the time body traces a curved path. Now, here, so what is the trajectory of the projectile? Here path of the projectile is parabola, path of the projectile is parabola. Now, here body moving two directions, Now, what are examples of projectile? Here a cricket ball thrown by a fielder, simple thing, a body projected into air, here other than 90 degrees, with the horizontal, such a body is called projectile. Now, here to study the motion of a body, what are examples of projectile? A cricket ball thrown by a fielder, a javelin thrown by an athlete, are examples of projectile. Now, to study the motion of a body, its velocity, u can be resolved into two components. What are that? U cos theta and u sin theta, Here u cos theta, here velocity u is resolved into two components. What are that? U cos theta, u sin theta. U cos theta is along x axis, so it is called what? Horizontal component, and u sin theta is along y axis, it is called what? Vertical component. Here what we write? Velocity vector u bar is equal to u cos theta I cap plus u sin theta j cap, Now, this is initial velocity vector. What is theta? Angle of projection. U cos theta is the component of velocity along x axis, it is called horizontal component of velocity. U sin theta is the velocity along y axis, it is called what? Vertical component of velocity. Now, here body experiences acceleration always acting downwards, towards the center of the earth. That is why at the point of projection, O be the point of projection, angle between acceleration due to gravity and velocity at point of projection how much? 90 plus theta. Here acceleration due to gravity always acting downwards, towards the center of the earth. At point of projection, angle between acceleration and velocity how much? 90 plus theta. Now, here, so in oriental direction, as there is no acceleration in oriental direction, you know that acceleration due to gravity always acting downwards towards the center of the earth. Because of that, there is no acceleration in oriental direction. So, because of that, horizontal component of velocity u cos theta remains constant throughout the journey of the projectile. Now, even projectile at the maximum height, it has velocity u cos theta. Now, as there is no acceleration, here velocity is equal to what? U plus at. Now, there is no acceleration in oriental direction, ax is 0, ay is equal to how much? Minus g. Now, what is acceleration vector here? G into minus j cap, Now, as there is no acceleration, now v is equal to what? U plus at. Suppose if you take velocity, v is equal to u plus at. Now, in oriental direction how much? Vx is equal to how much? Ux plus Ax into t. Vx is equal to how much? Ux plus Ax into t. From this, Vx is equal to how much? Ux is u cos theta. Ax how much? 0. So, u cos theta, like that. As there is no acceleration in oriental direction, horizontal component of velocity u cos theta remains constant throughout the journey of the projectile, even projectile at the maximum height. Even projectile at the maximum height, it has velocity u cos theta. Now, here there is no change in velocity at each and every point. At each and every point, it has oriental component of velocity how much? U cos theta. Now, in vertical projection, in vertical projected body, at the maximum height, what happened? Final velocity is 0. But here in case of projectile, final velocity is not 0. Even projectile at the maximum height, it has velocity u cos theta. But here, whereas body is subjected to acceleration to gravity downward direction, acceleration to gravity acting downward direction. That is why u sin theta value goes on decreases. How? Here Vy is equal to how much? Uy plus Ay into t. Now Vy is equal to Uy plus Ay into t. From this, here Vy is equal to u sin theta minus Ay how much? G, like this. Vy is equal to u sin theta minus gt. That is why in vertical direction time goes on. So, in vertical direction Vy value, u sin theta value goes on decreases. Finally, it becomes 0 at the maximum height. Finally, it becomes 0 at the maximum height. After that again increases. Now, u sin theta value goes on decreases. Finally, it becomes 0 at the maximum height. After that again decreases. Now, so at each and every point in the trajectory of the projectile, at each and every point it has two velocities. One is horizontal component of velocity, one is vertical component of velocity. But at the maximum height, here u sin theta value becomes 0. So, it has only velocity u cos theta. And why? Because of this, there is no acceleration in oriental direction. Now, u cos theta is the minimum velocity of a projectile. U cos theta is the minimum velocity of a projectile, and a velocity of a projectile at the maximum height also u cos theta, like that. So, in oriental direction u cos theta constant, because of that change in velocity in oriental direction 0. Change in velocity means what? Final velocity minus initial velocity. So, change in velocity in oriental direction how much? 0. But in vertical direction, here u sin theta, here downward direction again we are getting u sin theta. Now, change in velocity how much in vertical direction? Here minus u sin theta minus 2u sin theta. In vertical direction only we have change in velocity. So, there is no change in velocity in oriental direction. Is it clear? So, you remember what is velocity of a projectile at the maximum height? U cos theta. That is the main difference between vertically projected body and projectile. Now, what is the angle between at the maximum height? What is the angle between acceleration and velocity? Here velocity, what is the direction of velocity at the maximum height? Here horizontal direction. So, at the maximum height, angle between velocity and acceleration is 90 degrees. At the point of projection means what? The point at which the body is projected. Now, at the point of projection, angle between acceleration due to gravity and velocity is 90 plus theta. At the maximum height, angle between velocity and acceleration is 90 degrees, like that. And from this, here, so what is velocity vector at maximum height? Velocity vector at maximum height, u bar is equal to, suppose v bar is equal to u cos theta I cap, You know that I cap, j cap are unit vectors along x y axis. Now, so what is acceleration vector? Acceleration vector is, we write like this, a bar is equal to g into minus j cap, like that. Now, we discuss here path of the projectile. Path of the projectile is parabola. We study the motion of a projectile. Now, anyhow, we know velocity in horizontal direction and vertical direction. Now, suppose let the projectile is at point P. After time t seconds. It has coordinates x and y. Now, we derive relationship between x and y. So, what is x here? Horizontal displacement. What is y? Vertical displacement. Now, x is the horizontal displacement, y is the vertical displacement. Now, we derive relationship between x and y. one more thing, we derive expression for we study about displacement of a projectile and velocity of a projectile and maximum height and range of a projectile, time of flight we discuss. Everything you already studied in motion in a straight line. Now, motion in a plane also we discuss time of ascent, time of flight and also range. What is range here? Now, first we discuss displacement of a projectile, after that remaining. Now, anyhow we got velocities. What is initial velocity vector? U cos theta I cap plus u sin theta j cap. What is theta? Angle of projection. What is u? Velocity, like that. Now, here now discuss displacement of a projectile. Displacement of a projectile. Suppose if the projectile is at point P after time t seconds, if the projectile is at point P after time t seconds, now Sx along Ox, now discuss along Ox, what is initial velocity? Ux is u cos theta, Ax how much? 0. Now time how much? T, time is equal to t. Now Sx is equal to how much? X, Sx is equal to x. Now how we calculate displacement? By using second equation of motion. What is second equation of motion? S is equal to what? Ut plus half at square. From this Sx, Sx is equal to how much? Uxt plus half Axt square, half Ax t square. Sx how much? X, Ux how much? U cos theta, u cos theta into t, Ax how much? 0. So x is equal to how much? U cos theta into t, u cos theta into t. This is the oriental displacement of a projectile in time t seconds. Again we calculate. So from this t is equal to how much we are getting? X by u cos theta, x by u cos theta. Again we calculate vertical displacement of a projectile. Now from this along Oy, here along Oy, vertical direction, what is velocity? Uy how much? U sin theta, Ay is minus g, Ay is minus g. From this here Ay is equal to minus g, time is equal to how much? T, Sy is equal to how much? Y, Sy is equal to y. Now by using second equation of motion, what is that? Sy is equal to Uy into t plus half Ay into t square, half Ay into t square. From this Sy how much? Uy how much? U sin theta, Uy how much? U sin theta, u sin theta into t minus half gt square. Now this is the vertical displacement of a projectile in time t seconds. This is oriental displacement. Here what is displacement vector now? Displacement vector S bar is equal to Sx I cap plus Sy j cap, Sx I cap plus Sy j cap. From this S bar is equal to Sx how much? X, x I cap plus y j cap, x I cap plus y j cap. X and y we know. X value how much? U cos theta, y value how much? U sin theta into t minus half gt square. Now this is the displacement vector in time t seconds. Now we substitute this t value, in this equation. This is second equation, this is first equation, now this is second equation. Now we are getting y is equal to u sin theta, t how much? X by u cos theta. On that time we are substituting t value in second equation from first equation. We are getting like this, tan theta into x minus g by 2u square cos square theta into x square. Here we are substituting t value, in second equation from first equation. We are getting y is equal to how much? Tan theta into x minus g by 2u square cos square theta. Now y is equal to, we take like this, ax minus bx square, ax minus bx square. Now this is the equation of a parabola. Y is equal to ax minus bx square. This is equation of a parabola. So trajectory of a projectile is parabola. Trajectory of a projectile is parabola, or path of a projectile is parabola. They will ask question, what is the path of the projectile? Path of the projectile is parabola. What is the trajectory of the projectile? Y is equal to ax minus bx square. What we are taking here? Let tan theta is equal to a. Let tan theta is equal to what? A, and g by 2u square cos square theta. 2u square cos square theta is equal to b. So on that time, what we are getting? Ax minus bx square. A and b are constants. What is theta here? Theta represents what? Angle of projection. Theta represents angle of projection. Now here what are x and y? x and y are the coordinates, x and y are the coordinates of position of a projectile, x and y are the coordinates of position of a projectile on the trajectory at the instant of time t seconds. Now, so x is the horizontal distance, y is the vertical distance. Now, what is the relation between x and y? X and y relation is the parabola equation. So, that is why trajectory of a projectile is parabola, trajectory of a projectile is parabola. So, how they are asking question? Suppose they are giving velocity, a body projected with 20 meter per second, angle of projection 30 degrees. Find the displacement vector. How we calculate displacement vector? S bar is equal to what? Xi cap plus yj cap. What is x? X is u cos theta, u cos theta into t. What is y? Vertical displacement. What is vertical displacement? U sin theta into t minus half gt square, u sin theta into t minus half gt square. This is the vertical displacement of a projectile. Now, sometimes they are giving trajectory of a projectile, find the angle of projection. Here what they are giving, suppose y is equal to root 3x minus some value 2x square. What is a? A is root 3, tan theta is equal to root 3. So, theta is equal to tan inverse root 3, angle of projection becomes what? 60 degrees, like that. Now, y is equal to ax minus bx square. What are a and b? A and b are constants. A is equal to how much? Tan theta. B is equal to what? G by 2u square cos square theta, like that. So, okay, this is about what is this? Trajectory of a projectile. Trajectory of a projectile is parabola. Now, and also we calculate direction. What is direction here? Tan theta. Tan theta is equal to what we write? Sy by sx. Sy by sx. Here already we took theta. Now, after time t seconds, what we take? Direction alpha. Now, tan alpha. Tan alpha is equal to what we are getting? Sy by sx. Sy by sx, like that. Next one, here next we discuss velocity of a projectile, velocity of a projectile after time t seconds. What is initial velocity vector? Initial velocity already you know that, initial velocity how much? U bar is the initial velocity. What is initial velocity vector? U cos theta I cap plus u sin theta j cap. Now we discuss velocity of a projectile. We discuss velocity of a projectile after time t seconds, velocity of a projectile after time t seconds. So, in examination where they are asking very simple questions, sometimes trajectory of a projectile they are giving, find the angle of projection, otherwise initial velocity. If you know b value, we calculate initial velocity. How we calculate now? Here suppose here angle of projection, how we calculate? Theta is equal to how much? Already explained, tan inverse A. Theta is equal to how much? Tan inverse A. Now, from this, if you know trajectory of a projectile, theta is equal to how much? Tan inverse A, like this. Now, from this, G is equal to what we write? 2u square cos square theta into B. Now, from this, u square is equal to how much? G by 2b cos square theta, 2b cos square theta. Now, 1 by cos square theta how much? Secant square theta, G into secant square theta by 2b. Now, G into secant square theta how much? 1 plus tan square theta. Now, 1 plus a square. What is A? A is tan theta. Now, G into 1 plus a square by 2b. Now, here this is u square. Now, u value how much? U is equal to under root of G into 1 plus a square by 2b. Okay. If you know trajectory of a projectile, we calculate angle of projection. How? The trajectory of a projectile means what is the trajectory of a projectile? Y is equal to ax minus bx square. Now, what is A? A is tan theta. So, if you know A value, we calculate angle of projection. How we calculate? Theta is equal to tan inverse A. And if you know B, we calculate initial velocity of projection. What is U? Initial velocity of projection. How much? Under root of G into 1 plus a square by 2b. G into 1 plus a square by 2b, like that. In this way, we calculate initial velocity of projection. And also, now discuss velocity of a projectile after time t seconds. Velocity of a projectile after time t seconds. Now, here initial velocity vector how much? Initial velocity vector is u cos theta I cap plus u sin theta j cap. Now, here velocity of a projectile after time t seconds. Velocity of a projectile. Here already explained initial velocity vector. Initial velocity vector how much? U bar is equal to how much? U bar is equal to u cos theta I cap plus u sin theta j cap. Now it is case velocity of a projectile after time t seconds, velocity of a projectile after time t seconds. So, first of all, along OX oriental direction, initial velocity how much, ux how much, u cos theta, ux is u cos theta, ax how much, ax is 0, time how much, time is t seconds. Final velocity what we are taking, Vx, we want to calculate, this is final velocity. How we calculate now? Here already explained that V is equal to how much, u plus at. Now Vx along oriental direction how much, Vx is equal to how much, ux plus ax into t. So Vx is equal to, Vx how much, u cos theta, ax how much, 0 into t. So Vx is equal to how much we are getting, u cos theta, Vx is equal to u cos theta. Here vertical direction along Oy, uy how much, uy is u sin theta, ay how much, minus g. Now vertical direction vy is equal to what, vy is equal to uy plus ay into t. So vy is equal to how much we are getting, u sin theta minus gt. Here vy is equal to uy how much, u sin theta minus gt. This is vertical direction. So now velocity vector how much, velocity vector v bar is equal to what we write now, vx I cap plus vy j cap, vx I cap plus vy j cap. From this v bar is equal to magnitude of v bar how much, under root of vx square plus vy square, like this. Vx how much, Vx is u cos theta, v bar is equal to what we write now, u cos theta I cap plus u sin theta minus gt, j cap. So from this what we understand here, in oriental direction, as there is no acceleration in oriental direction, so horizontal component of velocity u cos theta remains constant throughout the journey of the projectile. Now but in vertical direction its velocity goes on decreases, its in vertical direction its velocity goes on decreases, but in oriental direction velocity remains constant. Now velocity vector how much, u cos theta I cap plus u sin theta minus gt j cap, this is velocity vector. Now what is the direction of a velocity vector after time d seconds, initial how much, initially it makes an angle like this. Now if a body projected like this, so on that time initial velocity how much, initial direction of velocity, here angle of projection is theta. After time t seconds, t seconds, now this is Vx, now this is V, how much, let it be alpha. Now tan alpha is equal to what we write, tan alpha is equal to Vy by Vx, tan alpha is equal to Vy by Vx. Now alpha is equal to how much, tan inverse Vy by Vx, tan inverse Vy by Vx. What is alpha here? Direction of velocity, alpha gives direction of velocity after time t seconds. Suppose if a body reaches maximum height, velocity is in horizontal direction, but here body not reaches maximum height. Now let P be a point before reaching maximum height, now alpha gives what, alpha is the angle made by the velocity with the horizontal. Now what is velocity vector after time t seconds, u cos theta I cap plus u sin theta minus gt j cap, like that. This is about velocity of a projectile. Now and also we calculate here in time t seconds, we calculate velocity vector like this, and also distance travelled. Suppose it travels a distance how much, h, suppose small h be the height, in whatever may be the height, here horizontal direction velocity how much, oriental direction velocity always constant, whatever it may be, at each and every point velocity in oriental direction how much, u cos theta, like that. And suppose if we know, we do not know time, if we want to calculate velocity in vertical direction after time t, after travelling a height h, how we calculate now? By using third equation of motion, v square minus u square is equal to what, 2as, v square minus u square is equal to 2as. Now uy square how much, in oriental direction velocity constant, but in vertical direction Vy square is equal to what we write? Vy square minus Uy square is equal to 2Ay into Sy. How much on that time? Vy square becomes what? Vy square is equal to Uy square. U square sin square theta minus 2gh. So, this is the velocity Vy is equal to what? Under root of U square sin square theta minus 2gh. Like that we calculate. And next we discuss here a range and time of flight of a projectile, and also we discuss maximum height of a projectile. Now, anyhow in vertical direction u sin theta value goes on decreases. So, vertical direction velocity value goes on decreases, finally at the maximum height its velocity becomes how much? 0. So, u sin theta value at the maximum height, vertical component of velocity in vertical at the maximum height how much? 0. So, what is maximum height? Maximum vertical distance travelled by the projectile. Maximum vertical distance travelled by the projectile is called what? Maximum height. And also we have time of flight. What is time of flight? Total total time taken by a projectile to travel along its trajectory. You already studied motion in a straight line, you know time of ascent and time of descent and time of flight. What is time of ascent? Time taken by a body to reach maximum height. Here also same thing. Time taken by a projectile to reach maximum height is called what? Time of ascent, and time taken by a projectile to reach ground from the maximum height is called what? Time of descent. What in vertical direction? What is velocity? U sin theta. Now, time of ascent, what we write now? Time of ascent is equal to Uy by g. Time of ascent how much? Uy by g. Now, time of ascent becomes Uy how much? U sin theta by g. Time of ascent is U sin theta by g. Again time of descent also U sin theta by g. Now, we calculate total time of flight. What is time of flight? Total time spent in air, or otherwise time taken by a projectile to travel along its trajectory. Total time taken by a projectile to travel along its trajectory is called what? Time of flight. Now, so what is time of ascent? Time of ascent is U sin theta by g. Time of descent also U sin theta by g. Now, time of flight how much? Time of flight becomes what? 2U sin theta by g. 2U sin theta by g. Now, we discuss time of flight. Time of flight. Here time of flight means what? Total time taken by a projectile to travel along its trajectory. Total time taken by a projectile to travel along its trajectory is called what? Time of flight. Now, here time taken by a projectile from the point of projection to maximum height is called what? Time of ascent. From maximum height to time taken by a projectile to reach the ground from maximum height is called what? Time of descent. Now, time of ascent is equal to time of descent is equal to how much? U sin theta by g. U sin theta by g. Now, time of flight. Time of flight is equal to what? Sum of time of ascent and time of descent. Now, t is equal to Ta. Ta how much? U sin theta by g plus U sin theta by g. So, from this time of flight how much? 2U sin theta by g. Time of flight is 2U sin theta by g, like this. Now, so what is U sin theta? U sin theta is the velocity in vertical direction. U sin theta is velocity in vertical direction. How they are asking question? At the end of time of flight. At the end of time of flight, displacement of a projectile how much here? What is vertical displacement here? Vertical displacement starting is from the origin. So, at the half of the time of ascent, vertical displacement of a projectile how much? H. But at the end of time of flight, vertical displacement how much? 0. At the end of time of flight, vertical displacement of a projectile. We know how we derive this. Already you know that displacement of a projectile in time t seconds. What is that? Y is equal to what? U sin theta into t minus half z square. But if small t is equal to capital T, at the end of time of flight, vertical displacement of a projectile how much? 0. If in time period t, at the end of time period, vertical displacement of a projectile how much? 0, like that. And also, what is the horizontal displacement here? During time of flight, horizontal distance travelled by the projectile. During time of flight, horizontal distance travelled by the projectile is called what? Here range. What is range? Horizontal distance travelled by the projectile. Horizontal distance travelled by the projectile during time of flight is called what? Range. Now, so horizontal displacement. Already we know that Oriental displacement how much? Sx is equal to how much? U cos theta into t, U cos theta into t. Now, if t is equal to, capital T, t is equal to capital T how much? 2u sin theta by g. On the time Sx is equal to U cos theta into, how much here? Capital T. So, we are substituting time of flight value U cos theta into what we are getting? 2u sin theta by g, 2u sin theta by g. So, on that time we are getting here oriental displacement t is equal to t, Sx is equal to what? R. From this R is equal to, we substitute now, we are getting u square 2 sin theta cos theta by g, 2 sin theta cos theta by g. So, from this R is equal to u square sin 2 theta by g, u square sin 2 theta by g. This is the range of a projectile, u square sin 2 theta by g. Now, what is u here? U is the initial velocity. Now, what is theta? Angle of projection. Now, range of a projectile, how much? U square sin 2 theta by g, u square sin 2 theta by g, like that. What is range? Oriental distance travelled by the projectile during time of flight. Oriental distance travelled by the projectile during time of flight is called what? Range. Now, when this range is maximum, so what is in diagram, how we represent? This only, from here to here is called what? Range. Now, what is the average velocity of a projectile during time of flight? Average velocity how much here? How much displacement here? U cos theta into t. Now, average velocity means what? Ratio of total displacement by total time. Now, average velocity, V average is equal to what? Total displacement by total time. Total displacement how much during time of flight? U cos theta into t. So, by t. So, what is the average velocity of a projectile? U cos theta. Here U cos theta is the, what I told, U cos theta is the velocity, horizontal component of velocity, and U sin theta is the, U cos theta is the horizontal component of velocity, and also minimum velocity of a projectile, and also what we call average velocity of a projectile. Average velocity how we calculate? Total displacement by total time. Total displacement how much? U cos theta into t. Time how much? Time of flight. So, what is Tt gets cancelled? We are getting here average velocity of a projectile how much? U cos theta. U cos theta, what we say? U cos theta is the horizontal component of velocity and minimum velocity of a projectile, and also what we call average velocity of a projectile. Average velocity of a projectile, like that. Now, this range, when range is maximum, now range, this range is maximum here for a given velocity of projection, u and g are constants. Now, range of a projectile is maximum when sin 2 theta value is maximum, when sin 2 theta value is maximum. When sin 2 theta is maximum, for what is the maximum value of sin? For which angle? 90 degrees. So, sin 90 is 1, that is maximum angle, maximum value of sin. So, 2 theta is equal to, we take 90 degrees, 2 theta is equal to 90 degrees. Now, 2 theta is 90 degrees means what? Sin 90, sin 90 is maximum. Now, range is same, range is maximum, for angle of projection how much? 2 theta is 90 degrees. So, 2 theta is 90 degrees means what? Theta how much? 45 degrees. Now, here range, now range is maximum, this range value how much? R is equal to how much? U square sin 2 theta by g. Now, for a given u and g are constants, now range is maximum, when sin 2 theta is maximum. What is the maximum value of sin 90 degrees? Sin 90 is 1, so 2 theta is 90 degrees. Now, theta how much? 90 by 2, how much? 45 degrees. Now, on the time range is maximum, R maximum is equal to U square into sin 90 by g. Sin 90 how much? 1. So, R maximum is equal to U square by g into 1. How much now? R maximum is equal to U square by g. R maximum is equal to how much? U square by g. What is the R maximum? Maximum range of a projectile. What is maximum range of a projectile? If the angle of projection is 45 degrees, angle of projection is 45 degrees, range is maximum. R maximum is equal to how much? U square by g. R maximum is U square by g. What is U? Initial velocity of projection. What is g? Acceleration due to gravity. And also, now when range is same, at what angles? Range is same for angles of projection. Now, theta and 90 minus theta. Now, theta and 90 minus theta. Why? Sin 180 minus 2 theta how much? Sin 2 theta. That is why range is same for angles of projection. Theta and 90 minus theta. Theta and 90 minus theta are called what? Complementary angles. Theta and 90 minus theta are called what? Complementary angles. Now sin 180 2 into 90 minus theta, sin 180 minus 2 theta. Sin 180 minus 2 theta how much? Sin 2 theta. That is why range is same for angles of projection. Theta and 90 minus theta means what? Theta 30 degrees, it becomes 60 degrees. Suppose if you take 45 and also what we write 45 minus theta, 45 plus theta. 45 minus theta and 45 plus theta. Suppose if you take 40 and 50, 90 minus 40, 50 like that. So range is same. Range is same means what? Suppose this is theta. 90 minus theta means what? Like this. Here theta 1 and theta 2. Theta 1 and theta 2 like this. Theta 1, theta 2. Theta 1 is 30 degrees. Theta 2 becomes what? 60 degrees. Now range is same for angles of projection. Theta and 90 minus theta. Theta and 90 minus theta like that. So it is also important. And also now what I explained, what is this R maximum? R maximum is the maximum range. Now discuss maximum height of a projectile. Maximum height of a projectile. Here already explained, if a projectile, what is the trajectory of a projectile is parabola. Now maximum vertical distance travelled by the projectile. Maximum vertical distance travelled by the projectile is called what? Maximum height. Here already we know that here u cos theta and u sin theta. U cos theta and u sin theta is the initial velocities in horizontal and vertical direction. Now what is maximum height of a projectile here? Along vertical direction, what is initial velocity? U sin theta. U acceleration how much? Ay is minus g. Now displacement Sy is equal to what? H. Sy is equal to H. H is the maximum height of a projectile. Now we final velocity how much? At the maximum height, final velocity of a projectile how much? 0. Now vertical direction velocity is 0. Now substituting the values in third equation of motion. What is that? V square minus u square is equal to what? 2as. From this Vy square minus uy square is equal to what? 2ay into sy. 2ay into sy. From this Vy is 0, uy how much? U sin theta. U square sin square theta minus 2g into h. So from this h is equal to how much? U square sin square theta by 2g. U square sin square theta by 2g. This is the maximum velocity, maximum height of a projectile. Now if g and g are constant, h proportional to sin square theta. H proportional to sin square theta like that. Now if a body projected with the angles of projection theta and 90 minus theta, if the complementary angles, if theta 1 is theta, theta 2 is 90 minus theta. Now on the time h1 plus h2, if theta 1 is theta, theta 2 is 90 minus theta. On the time theta 1 is theta, how much? H becomes what? U square sin square theta by 2g. Theta 2 is 90 degrees, 90 minus theta. So on the time h2 becomes what? U square sin 90 minus theta how much? Cos theta. U square cos square theta. So on the time h1 plus h2 is u square by 2g. If a body projected with complementary angles, h1 plus h2 how much? U square by 2g. And also we write here already we know trajectory of a projectile. What is trajectory of a projectile? Here y is equal to how much? Ax minus bx square. Y is equal to ax minus bx square. Here from this also we calculate, here y is equal to ax minus bx square. Now we write what is the value of maximum height? How much we are getting? H is equal to a square by 4b. H is equal to a square by 4b. And also range of a projectile how much? R is equal to a by b. R is equal to a by b. So directly we calculate. So range of a projectile is a by b. Maximum height of a projectile how much? A square by 4b. A square by 4b like that. And so at the maximum height, here, so this is the maximum height. maximum height means what? Maximum vertical displacement of a projectile from the ground. Maximum vertical displacement of a projectile from the ground is called what? Maximum height. So, depends on these we have problems, and also we discuss horizontal projection of a body from the top of a tower. Now, this is oblique projectile. Oblique projectile means what? Body projected some angle, body projected with the some angle with the horizontal. Now, it is the oblique projectile, and also we discuss now here what is that? Horizontal projectile, horizontal projection of a body from the top of a tower. Now, here is it clear? What is maximum height of a projectile? U square sin square theta by 2g. What is theta? Angle of projection. Theta represents what? Angle of projection. Now, discuss horizontal projectile, horizontal projection of a body from the top of a tower. Now, discuss horizontal projection, horizontal projection of a body, horizontal projectile, simple thing, horizontal projectile or horizontal projection of a body from the top of a tower, like this. We consider a tower of height h. Let a body is projected, horizontally with a velocity u from the top of a tower. So, on the time horizontally angle of projection how much? Theta is 0. Here there is no angle of projection, body is projected like this, angle of projection is 0. Now, body is projected horizontally from the top of a tower. On the time here immediately it is attracted by the earth, that is why. So, like this it follows like this, it follows parabolic path. Now, here angle of projection theta is 0, ux how much? Ux how much? U cos 0, cos 0 how much? 1, u into cos 0 is 1 u. Vertical direction uy how much? U sin theta, u sin 0, sin 0 how much? 0. So, u into 0 0. So, if a body projected horizontally, horizontal component of velocity how much? Ux is u, uy how much? Uy is 0, uy is 0. So, in vertical direction uy is 0, ux how much here? Ux is equal to u, ux is equal to u. What is initial velocity vector here? U bar is equal to ui cap, or in horizontal component of velocity, here velocity of a projectile how much? Ui cap, ui cap. Same thing now, here if a body projected horizontally from the top of a tower, so it is attracted by the earth, it experiences acceleration due to gravity in downward direction, Suppose let the body reaches at point P after time t seconds. So, on the time what is the horizontal distance now? X is the horizontal distance, y is the vertical distance, like this. We derive relationship between x and y, Now, we calculate displacement of a projectile. Now, in horizontal direction we know velocity. Here ax how much? Ax is 0, ay is equal to how much? G, downward direction we take plus. Now, here horizontal direction how much? Displacement, Sx is equal to how much? Uxt plus half axt square. From this Sx what we are taking? X, ut, ax how much? 0, x is equal to ut. This is the horizontal displacement of a projectile in time t seconds. Again we calculate vertical displacement. How much here? Sy. Sy is equal to what we write? Uy into t plus half a by t square. From this Sy how much? Y. Uy 0 plus half gt square. So, vertical displacement of a projectile how much? Half gt square. Here horizontal displacement is ut, vertical displacement how much? Half gt square. Now, displacement of a projectile, here from this t is equal to what we write? X by u, t is equal to x by u, y is equal to how much? Half g t square, x by u whole square. From this what we are getting? Y is equal to g x square by 2u square. Now, g by 2u square is constant. So, what we take now? Ax square. Y is equal to ax square. This is also equation of a parabola. So, trajectory of a projectile, what is that? Here if a body projected horizontally from the top of a tower, on the time also trajectory of a projectile is parabola. Y is equal to ax square. What are x and y? X and y are the coordinates. Of position of a particle on the trajectory at the instant of time t seconds. So, relation between x and y is parabola. So, that is why trajectory of a projectile a trajectory of a body thrown horizontally from the top of a tower is also parabola. What is parabola equation here? Y is equal to ax square, y is equal to ax square. Now a how much here? A value how much? G by 2u square. A is equal to G by 2u square. From this, u square is equal to how much we write? G by 2a, G by 2a. Now u is equal to how much? Under root of G by 2a, like this. And also we calculate velocity of a projectile. What is initial velocity vector? u I cap. I cap means what? Oriental direction. Here also what we understand, as there is no acceleration in oriental direction, as there is no acceleration in oriental direction, so oriental component of velocity u remains constant everywhere. In oriental direction everywhere, oriental velocity how much? U only. But in vertical direction initial velocity 0. Why 0? U sin 0, sin 0 how much? 0. So in vertical direction its velocity goes on increases. In vertical direction its velocity goes on increases. Now we discuss velocity of a projectile also. Now we discuss velocity of a projectile. Velocity, here body projected horizontally like this. Now after time t seconds, here velocity of a projectile is v. Now Vx and Vy, Vx and Vy are the velocities. Initial velocity how much? Initial velocity is u, ux how much? U, ux is u. Initial velocity vertical direction how much? 0. Now after time t seconds, v be the velocity of a projectile. After time t seconds, v be the velocity of a projectile. Now ux is u. Now how we calculate velocity? V is equal to how much? U plus at. From this, Vx is equal to how much? Ux plus ax into t. Now from this, Vx is equal to ux how much? U, ax is 0. Now Vx is equal to u, Vx is equal to u. This is the velocity of a projectile in oriental direction. Vertical direction, Vy is equal to how much? Uy plus ay into t. From this, Vy, Uy how much? 0, ay how much? G. Now Vy is equal to gt, Vy is equal to gt. Now velocity vector what we write now? Vx I cap plus Vy minus j cap. Here in vertical direction, so what we understand here? In vertical direction, initial velocity is 0, but time goes on, here after 1 second, Vy is equal to what? G, after 2 seconds, Vy is equal to what? 2g, after 3 seconds, Vy is equal to 3g, like that. Time increases, in vertical direction its velocity increases, Vy is equal to gt. Now velocity vector how much? Velocity vector V bar is equal to Vx I cap plus Vy minus j cap, Vy minus j cap. What is magnitude of velocity? Magnitude of velocity is equal to under root of Vx square plus Vy square, Vx square plus Vy square. Now suppose if the velocity makes an angle alpha, if the velocity makes an angle alpha with the horizontal after time t seconds. Now initially how much? It is initially body projected horizontally, angular projection how much? 0. Now but here after time t seconds, here velocity of a projectile makes an angle alpha with the horizontal. Now tan alpha is equal to what we write? It is nothing but what? Vy. Now tan alpha is equal to Vy by Vx, tan alpha is equal to Vy by Vx. From this, Vy how much? Gt, Vx how much? U. So this is tan alpha. From this, alpha is equal to how much? Tan inverse Gt by U, tan inverse Gt by U. This is the angle made by the velocity after time t seconds, direction of velocity after time t seconds. Here initially it is horizontal, initially body projected horizontally, after time t seconds what happened? Here velocity of a projectile makes an angle alpha with the horizontal. So alpha gives the direction of the velocity of a projectile after time t seconds. Alpha is equal to how much? Tan inverse Gt by U. Suppose here alpha is, here sometimes 45 degrees. 45 degrees means what? U is equal to what? Vy and Vx are equal, Vy and Vx are equal, like that. In this way we discuss velocity of a projectile, and also we discuss time of flight of a projectile, Now time of flight, for this body there is no time of ascent. Why? Body projected from the top of a tower. So for this body there is no time of ascent, Now so time of descent how much here? Time of descent only time of flight of a projectile, time of flight of a body, time of flight of a horizontal projectile. What is time of descent here? Uy how much here in vertical direction? Uy is 0. Now Sy how much? H. Sy is H. Now we discuss time of descent of a projectile. Time of descent of a projectile. Now from this, here Uy is 0. Uy is 0. For the same thing, here Uy is 0. Sy how much? H. Uy is 0. Sy is H. Now time is equal to what we take? Time of descent. Time is equal to time of descent. Now Sy is equal to how much? Sy is equal to Uy into T plus of Ay into T square. Of Ay into T square. From this Sy H Uy 0 of Ay how much? G Td square. From this H is equal to of G Td square. Of G Td square. From this Td square is equal to how much? 2h by G. Now Td is equal to what? Root of 2h by G. Root of 2h by G. Now time of descent of a body. Time of descent of a body projected horizontally from the top of a tower. How much? Root of 2h by G. Now for this in this case, there is no time of ascent. Body projected horizontally from the top of a tower. That is why there is no time of ascent. Time of ascent is 0. Time of descent, how much here? Root of 2h by G. Now for this, from this what we understand? Time of descent or time of flight of a body projected horizontally from the top of a tower here depends on the height of a tower. Depends on the height of a tower. It is independent of initial velocity of projection. Now body projected, whatever may be the velocity, whatever may be the velocity, time of descent or time of flight, time of descent or time of flight depends on the height of a tower. As height of a tower increases, time of flight or time of descent increases. So it is independent of a conceptual question. Time of flight or time of descent, if a body projected horizontally from the top of a tower, is independent of initial velocity of projection. Independent of initial velocity of projection. It depends on what? Height of a tower. And also we calculate a range of a body. How we calculate range? Horizontal distance travelled by the projectile during time of flight. Now here what is horizontal distance? This only. Horizontal distance travelled by the projectile during time of flight is called what? Range. Like this. This is the range. How we calculate now? During time of flight how much horizontal distance travelled? This R. Here horizontal distance how much? Here already explained horizontal displacement of a projectile. Sx is equal to what? Ux into T. Now here what is T here? Time of flight. Time of flight how much we got? Time of flight is root of 2h by G. Now T is equal to capital T is equal to root of 2h by G. From this here Sx is equal to how much? Ux into T. Ux into T. Now T is equal to capital T. Sx becomes what? R. Sx is equal to R. Now we substitute here. Sx is equal to R. Here horizontal direction there is no acceleration. Ax is 0. Now Ux into T plus of Ax into T square. Now Ux how much here? Ux how much? U. T how much? T. Ax how much? 0. Now R is equal to U into T how much? Root of 2h by G. Here range of a body. Range of a body projected. Range of a body projected horizontally. Range of a horizontal projectile is equal to what? R is equal to U into root of 2h by G. Now here range of a body depends on initial velocity and height of a body, height of a tower. Here range of a body projected horizontally from the top of a tower depends on what? Initial velocity and height of a tower. But here time of flight and time of descent is independent of initial velocity of projection, like that. Is it clear? Now, so depends on these concepts you will get so many questions and problems. So read all synopsis and problems. What is U here? Initial velocity and H. What is H? What is H here? Height of a tower. H represents height of a tower.